Hello students, welcome back to the lecture series of inverse trigonometric function, and this is our lecture number 3. And in this lecture we are going to discuss the properties of inverse trigonometric function, rest of the properties of inverse trigonometric functions. So let us begin the video. So let us begin the class with property number 10, and up to property number 9 I have discussed in the previous 2 videos of this lecture series. So you may watch those videos just by going to my channel and search for inverse trigonometric function. And here the property number 10 tells us that sin inverse x plus sin inverse y is equal to, there are two different formulas given under certain conditions on x. This is the principal branch condition. Actually x and y, these are between -1 and 1, and x square plus y square, this is less than 1. This is representing actually the principal branch, and it is equal to pi minus this one under these conditions. Okay, so if you take some more different conditions on x and y, that is there may be another condition that this x may be less than 0 and less than equal to this one, or y, this is also maybe one condition as well. In this case also, x square plus y square may be less than 1, or x square plus y square may be greater than 1. So for each of these conditions we will have some formula for sin inverse x plus sin inverse y, but my recommendation is to just memorize the formula for the principal branch only. That is, you just memorize this one. This formula, some other formula will also be there. I am discussing about all of them. Those formula is actually not much more usable. You just memorize this one, and those can be obtained under given condition. What will be the formula? That will be depend upon these values of x and y. So I am not discussing those one, just I am taking only 2 formula here. So let us prove this formula. Okay, so the first one, you see, let me take this sin inverse x equal to a and sin inverse y is equal to b. Simple. And then here x and y, this is between -1 and 1, and y, a and b, these are is in the principal branch, therefore they are in between -pi/2 and pi/2. Okay, so this x is equal to sin a, y is equal to sin b, and ab belongs to -pi/2 plus pi/2, because this was the principal branch, and you can recall them from the definition of sin inverse x function. Okay, so this is the given condition tells us. And so after that, you see, since x is equal to sin a and y equal to sin b, then we can find the cos a and cos b also, like this. Cos a is equal to root over, actually cos a is equal to what? Root over 1 minus sin a, and sin a is equal to x, so that is equal to 1 minus x square and then root over. Similarly, cos b is equal to root over 1 minus sin square b, and sin b is equal to y, so it is root over 1 minus y square. Now we just find these conditions, x square plus y square less than 1 and this. So case 1, I am taking these conditions. So these are the formula for sin a plus b and sin cos a plus b. These two will be used later on. So this value is x, this value is 1 minus y square. Just putting these values, actually just putting the values of sin x and cos x in this formula and here also. Okay, then case 1. So case 1 is this one, and from here, from the second one, it is actually x square plus y square is less than equal to 1, and actually I am finding this 1 minus x square and 1 minus y square. So that is 1 minus x square, this 1 minus x square will be greater than y square, and 1 minus y square will be greater than x square. Just taking the product here side by side. So 1 minus x square into 1 minus y square will be greater than y square x square or x square y square. Just writing that one. And after that, here you see here we need root over 1 minus x square into root over 1 minus y square minus xy. So first of all, I am taking here the square root and then shifting this xy to the left. So first taking square root, so it is root over 1 minus x square 1 minus y square. This is xy only, and shifting to the left, it is greater than or equal to 0. And this is actually the value of cos a plus b. So I am writing here cos a plus b is greater than 0. So this was the first previous line. So cos of a plus b is greater than or equal to 0. And when cos of a plus b is greater than or equal to 0, we know that one when the cosine function is positive. In which quadrant you already know, it is positive in the first and the fourth quadrant, because the ASTC rules tells us, ASTC rule, you already know that the ASTC rule like this, ASTC rule tells us that here all trigonometric ratios are positive and here cos is positive. So cos is positive from here and here. In these two quadrants, cos is positive, and here the angle is a plus b. You see, a plus b, angle is cos a plus b. Therefore we can conclude that a plus b is positive here. A plus b is in this branch, it is minus pi by 2 actually, and this is pi by 2. Is that clear? Minus pi by 2 up to pi by 2. A plus b will lie on minus pi by 2 up to pi by 2. You see that one. So a plus b lies either in the first quadrant or in the fourth quadrant. So we can say that a plus b, it is from minus pi by 2 up to pi by 2. But actually a plus b is in which branch? You just recall in the previous screen, you see where a was situated. A was situated in the branch minus pi by 2 up to pi by 2. You see in your copy, and b is also situated in that branch, that is from minus pi by 2 up to pi by 2. Then adding this, it is minus pi by 2 minus pi by 2 is minus pi, less than is equal to, it is a plus b only, and less than is equal to, this is pi by 2 plus pi by 2 will be equal to pi only. So that is why I am writing this part here. Okay, so but actually from this condition, that means a plus b is in the first and fourth quadrant. From that condition we conclude that a plus b, this is actually in which quadrant? It is actually in minus pi by 2 and pi by 2. Now actually I am taking the intersection of these two, this and this. This is from minus pi up to plus pi. Minus pi up to plus pi mean where to where? You see here, minus pi up to plus pi is where to where? Minus pi is this minus pi, and plus pi is this, that is a complete rotation or revolution. And minus pi by 2 up to plus pi by 2 is in this portion. So our common section is from minus pi by 2 up to pi by 2. So I am clearing this screen. So that is written here. So from these two, that means a plus b is in the first and fourth quadrant, and this one minus pi plus minus pi less than is equal to a plus b less than is equal to pi, and so combining these two we can conclude that a plus b is actually in minus pi by 2 and pi by 2. So that means it is in the principal branch of the sine function. So in principal branch of sine function, sine a plus b is equal to sine a cos b plus cos a sine b. So I am writing that one. So therefore one implies sine a plus b will be equal to sine a cos b cos a sine b, and that is already x into root over 1 minus y square and y into root over 1 minus x square. It is already written in the previous screen, and you can see from here. And after that, this a sine can be taken on the right hand side as inverse function. So a plus b will be equal to sine inverse of this one, and just finally replacing the value of a and b. So what was the value of a? It was sine inverse x, and the value of b is sine inverse y. So just writing that two values on the right hand side, it is remaining same. So we proved this formula for the principal branch of the sine function. Now taking the second case. So now this is our second case. Second case is x greater than 0, y greater than 0, and x square plus y square is greater than 1. So in this case, x greater than 0 mean up to what? X greater than 0 mean it cannot be more than 1 actually. Okay, it cannot be more than 1, because in the definition of sine inverse function, the numbers written inside sine, this number should always between -1 and 1. But as per the given condition, x is greater than 0, so this negative branch is eliminated. It is less than up to 1. This is our condition actually. But what was x? X was equal to sine A. So it is 0, it is sine A, and this is 1. Taking inverse here, it is 0 A pi by 2. Okay. In the similar way, for y also, it will be 0 less than is equal to b less than is equal to pi by 2 in case of y. Okay. So now you see the solution here. Proceed as in the previous case. Here the second case is this one, x square plus y square greater than 1. So 1 minus x square, 1 minus y square, we need this value. Why? Because actually our target is to find this root over of 1 minus x square into root over of 1 minus y square minus xy. Whether this total expression is less 0 or greater 0, that should be our target, as well where the angle A and B and A plus B situated. That is our main target actually. So you take the product here. By side, 1 minus x square, 1 minus y square, and on the right hand side it is x square, y square. So it will be less, and then taking square root and shifting xy to the left. So this is, I am erasing this, you see this one. Okay, so after that, actually what was the value of this? Root over 1 minus x square, and this value is actually cos of a plus b. That is already discussed in the previous screen. So this is cos of a plus b, and finally we got here that cos a plus b is equal to 0, is less than 0, not equal to. Cos a plus b is less than 0. And so cos a plus b is less than 0 mean in which quadrant a plus b is lying? It will be in the second quadrant or in the third quadrant, because we know that cos is negative in the second and third quadrant, positive in the first and fourth quadrant. So from this line we can conclude that a plus b is lying in the second or in the third quadrant. So I am writing that one, a plus b mean the angle inside cos is second or in the third quadrant. But already I discussed this, that a is actually from 0 to pi by 2 and b is actually from 0 to pi by 2. So finally what is this? 0 up to pi, a plus b is lying inside 0 up to pi, just adding 0 plus 0, a plus b, pi by 2 plus pi by 2. So it is pi, and it is starting from 0 up to pi, the value of a plus b lying. So from the given conditions, a plus b is lying here, and from the second condition, this condition, a plus b is lying in the third and second quadrant. Now we are to take the intersection of these two portions actually. So but this result is this one. You may write in your copy as a side note here. So a plus b is actually from 0 to pi. From these two, that is just taking intersection. So it is from second or third quadrant. So you see here, I am writing here, second or third quadrant mean what? A plus b is in the second quadrant. That means what? A plus b either in the second quadrant or in the third quadrant. So is it not starting from pi by 2 up to pi? It is starting from pi by 2 up to pi. But here you see, here a plus b where? A plus b is inside 0 up to pi. So now what is the common part of these two? The common part of these two is simply pi by 2 less than is equal to a plus b less than is equal to pi. This is our common part. This is our common part. Okay, so I am writing that one. So pi by 2 up to pi, this one pi by 2 up to pi. But a plus b, I am finding the formula for sine inverse sine inverse x, sine inverse y, that is a plus b. But a plus b, this is angle of sine, and sine branch of principal branch of sine, that means it is not in the principal branch of the function sine. From pi by 2 up to pi, it is not in the principal branch of sine. What is the principal branch of sine? Sine principal branch is from minus pi by 2 up to pi by 2. So you see here, I am writing there. I am writing here. Okay, just watch here. You can copy after that. First you see, then you copy. Okay. So you see here, actually, finally we got this pi by 2, then less or equal, less than not equal to. I am erasing that. I am erasing this. Okay. So you see pi by 2, then here it is a plus b, it is a plus b, and then it is pi only. Okay, after that I already told you that a plus b should lie in between where? This angle, not a plus b, the angle should lie between minus pi by 2 up to pi by 2, because this is the principal branch of the function sine inverse function. In case of sine inverse function, the principal branch is from minus pi by 2 up to pi by 2. But here we obtained, this is not minus, here we obtained it is from pi by 2 up to pi. So to make this or to bring this to this principal branch, I am taking a minus pi on all sides. Actually this one, pi by 2 is already here, taking minus pi here, then a plus b is already here, then taking minus pi, and then pi minus pi. So this is our next line, minus pi by 2, then a plus b minus pi, and here it is 0. So now it is in the principal branch, or you may also take a negative sign product to take it in the first quadrant. You can also start with this. You can solve this or prove this theorem from this line also, but for our convenience I am taking a negative sign product, then 0 will become here, pi minus a plus b will be there, then pi by 2 will be there. Just taking a negative sign product and writing in this way. Now it is in the principal branch. So now start with the actual theorem. Actually it was, I am erasing this, you see here. Okay, so it is, sine of pi minus a plus b. It is also sine a plus b. It is from equation number 1 actually. So sine of a plus b can also be written as sine of pi minus a plus b, because in the second quadrant sine is also positive. So sine of pi minus a plus b is equal to that. Then take this sine to the right hand side inverse. So pi minus a plus b will be equal to this one. Then a plus b will equal to pi minus this total part. So it is the previous line. So a plus b will be equal to, a plus b is to the right hand side and this is coming to the left hand side. So it is pi minus sine inverse this one, and finally putting the value of a and b only. So it is sine inverse x plus sine inverse y is equal to this one. So in this way we can find more formula for sine inverse x plus sine inverse y for the different values of x and y. So next we take another property 10b, cos inverse x plus cos inverse y is equal to this one. Here I am taking only one formula just for x greater than 0 and y greater than 0. Okay, so there may be some other formula, x may be less than 0, y greater than 0, then cos inverse x plus cos inverse y will come with some pi or pi plus or pi minus, or minus pi plus or minus pi plus or minus pi minus. Something will become here after taking different conditions on x and y. Okay, so this can be proved by the similar way as done in the previous one. I think you can solve this. Just take it is cos inverse x as a, cos inverse y as b, as in the previous case. Okay, so x will be equal to cos of a, y will be equal to cos of b, then sin a must be equal to root over 1 minus x square. Similarly, sin b is also is equal to root over 1 minus y square. Then sin x greater than 0 and y greater than 0, using that result, x greater than 0 mean what? Cos a greater than 0, cos a greater than 0. Before that you should write cos of a plus b formula. Cos of a plus b formula is cos a cos b minus sin a sin b. You should write this, sorry, sin b. Then finally you will get cos of a plus b is equal to, this is b, a plus b equal to cos a cos b mean xy, and then minus root over 1 minus x square into root over 1 minus y square. Then by taking this cos a as inverse in the right hand side, and finally putting the value of a and b also, as well by these conditions, x greater than 0 and y greater than 0. X greater than 0 mean what? X mean cos a greater than 0 and cos b greater than 0. This cos a greater than 0, cos b greater than 0, and therefore cos a is in the first or in the third quadrant. In this way you can find this result. It is not necessary, actually it is not necessary, because obviously it is in the principal branch. So now this one, tan inverse x plus tan inverse y is equal to this. There are two formulae, first one and second one, and under certain conditions, x and y greater than 0 and xy less than 1, and second one, xy greater than 0, xy greater than 1. So when the product xy is greater than 1, then the formula will come with pi plus, the formula is same, tan inverse x plus y divided by 1 minus xy. So in this case also, you just takes tan inverse x is equal to a, tan inverse x is equal to a, and tan inverse y is equal to b. So writing this one, and so x is equal to tan a and y is equal to tan b, this one. Okay, so after that you impose this condition, xy less than 1, mean the actual formula for tan of a plus b is equal to, I am writing that one. So tan of a plus b equal to tan a plus tan b divided by 1 minus tan a into tan b. Why I am taking tan of a plus b? Because this is taken as a, this is taken as b. So a plus b is here, and this tan is taken in this side. So it will be tan a plus b. That is why I am expanding the formula for tan a plus b. Now tan a and tan b putting here, tan a is equal to x, tan b is equal to y. So using these values here, tan a plus b equal to x plus y divided by 1 minus xy. Now impose these conditions for the first case. So case 1 is x greater than 0, y greater than 0, and xy, the product is I think this should be less than 0. Then you see x is positive number, y is positive number, therefore x plus y is also positive. And since xy, this one xy is less than 0, then 1 minus xy, you see here, we have the condition is xy less than 1, so confirmly 1 minus xy, this is greater than 0. Okay, so as well you already obtained x plus y is also greater than 0, because individually x and y are positive number, so sum of two positive number is also positive, and that is why x plus y divided by 1 minus xy, this is also greater than 0, and that is writing here. That is, I am writing here. Okay, so but x plus y divided by 1 minus xy is nothing but, from equation number 1 we see that this is equal to 10a plus b is greater than 0. But when 10a plus b greater than 0, so angle is a plus b now. So what is the conclusion? A plus b lies in which quadrant? 10 function is positive in the first quadrant or in the third quadrant. So I am writing that one only. You see, just clearing the screen. You see here. So a plus b lies in the first or in the third quadrant. Okay, but actually x greater than 0 and y greater than 0 for the 10 function, principal branch is from minus pi by 2 up to plus pi by 2 open interval. So using that result also, a plus b is in the first or third quadrant, it was the previous line. But x greater than 0 mean a should be belongs to 0 up to pi by 2. You see this one, I am writing here for you. Actually the condition is x greater than 0. This means what? The substitution for x was 10a, 10a greater than 0, and so a is greater than 10 inverse 0. So a is greater than 0 angle, mean it should not be negative angle. So actual range of 10 function was from minus pi by 2, here is the angle, and here up to pi by 2, but a is positive angle, so we should avoid this. It should be starting from 0, angle is a, and it is going to up to pi by 2, and that is written here. In the similar way, b is also greater than 0, and that will also give us 0 up to pi by 2 is the range for b. Now add up this, and it will show that a plus b is from 0 to pi. A plus b is from 0 to pi. Now combining these two, this one and this one, combining these two, the first one tells us a plus b is in the first and third quadrant, either here or here, and this is telling us it is from here to here. So the common range is this part, mean from 0 up to pi by 2. So a plus b should be from 0 up to pi by 2. So from these two we can say a plus b is from 0 up to pi by 2, and then it is the principal branch of 10. Therefore 10a plus b, from equation number 1, 10a plus b is equal to simply x plus y divided by 1 minus xy. So 1 implies x plus y divided by 1 minus xy, and shifting this 10 to the right hand side, not shifting, taking inverse on the right hand side. So a plus b is equal to 10 inverse of x plus y divided by 1 minus xy, and so this will give us giving the value of a and b only. A was 10 inverse x and b was 10 inverse y. So 10 inverse x plus 10 inverse y is equal to this, and this is the proof of the first part, that is under the condition x greater than 0, y greater than 0, and xy product is less than 1. And come to the next one, case 2. Now this is our second case, when a greater than 0, x greater than 0, y greater than 0, and xy is greater than 1. So what is the conclusion of this? You see here, x greater than 0, y greater than 0, x greater than 0, y greater than 0, you see y is also greater than 0, then the sum of these two positive numbers, mean x plus y, is also greater than 0. X plus y is also greater than 0. As well, for the second condition, mean xy is greater than 1, and it will give us a 1 minus xy, this is less than 0. You see here, this part is positive number and this part is negative number, and therefore we can write here x plus y divided by 1 minus xy. This is a negative number because of this term. Numerator is a positive number, denominator is a negative number, so resulting term is a negative number. But actually x plus y divided by 1 minus xy is what? Is 10 of a plus b, and 10a plus b less than 0 which implies that a plus b, the angle a plus b, this is either in the second quadrant or in the fourth quadrant. Okay, so that is written here, x plus y divided by 1 minus xy, this is less than 0, then tan a plus b is also less than 0, and so a plus b lies in the second or in the fourth quadrant. Now actually a plus b is where? I should write that one. I am erasing first this. Okay, so now you see in the first part x is greater than 0. You see x is greater than 0. So what was x? X is now tan a. Tan a is greater than 0, where a is the angle. Now in case of tan function, the principal branch is, that means the angle should be from minus pi by 2 up to pi by 2 in case of tan. This is the principal branch of any tan function, and here angle is a. But you see here tan a should be a positive number. So tan a, if you take a as a negative part, then tan of negative number will give us a negative number. But we have tan a is a positive number, therefore we are to avoid the negative branch as like this. We should avoid negative branch as like this. In the similar way, we have y greater than 0, therefore from that one we will get 0 less than b less than pi by 2, and combining these two, that is adding these two, we will get a plus b. This angle will lie from 0 up to pi, just adding. So 0 up to pi, this is actually a plus b is lying. So I am writing that line. So also 0 less than a plus b less than pi. Now you see, you are to take the common portion of these two results. The common portion. So what is the common portion? You see here. The first one tells us that the angle a plus b is either in this quadrant or in this quadrant. This is the first case. And secondly, it is telling us that it will lie, mean a plus b will lie from 0 up to pi. And what is the common part? This part is common. And this part is mean what? It is the angle pi by 2, and this is the angle pi. So we will have to write that a plus b should be from pi by 2 up to pi. This is the common part of these two inequalities. Okay, so I am writing that. So from these two we will have this. Now again you see here, I am writing here. Again you see, already we got that a plus b, this is from pi by 2 up to pi. But actually tan a plus b, our original function was what? Tan of a plus b. So where this a plus b should lie? A plus b should lie in this branch actually. Okay, a plus b should lie in this branch. So we are to modify this expression or this inequality so that it comes to this branch, and to do that, just taking a negative pi on all sides, that is in this way, and in this case pi minus pi here, obviously that is 0. So in the left hand side it is minus pi by 2, and here we will have a plus b minus pi is there, then it is 0. So obviously you can solve the problem or proof from this line, but for our convenience I am taking another line by taking a negative sign into. If you take a negative sign product, then it will be pi by 2. This inequality sign will be reversed. It is pi minus a plus b, and this is reversed 0, and that is written in this way. 0 is writing in the left, then pi minus a plus b, then pi by 2. So it is actually this one. Okay, so now again you see, in equation number 1 you consider very conceptual, huh? So in equation number 1 the left hand side was tan of a plus b. Left hand side should be tan of a plus b, but using this angle inside 10, if we use this angle, we must use this angle. Okay, we must use this angle now, but it will conclude that it is a negative 10 a plus b, because 10 of pi minus something is equal to minus of 10. That it is in the second quadrant actually. So if I use this angle, then it will finally give us a negative of 10 a plus b. But in equation number 1, you will see that it was 10 a plus b. So to remove this minus, I am actually taking in 1 as like this, minus of 10. If I write like this, pi minus a plus b, then you see it will give this only 10 a plus b, because this is actually negative 10 a plus b, and this negative is already here, so this two negative combines as a positive sign. So I am writing that, you see here, this one. Okay, so then push the negative sign inside the 10 function, this negative sign, and that can be written like this, 10 of, it will be positive, so a plus b minus pi, this is this one. And we can use this one because 10 minus theta is equal to minus 10 theta, so this minus can be taken inside as like this. Then 10 is taken on the right hand side as inverse, then pi is taken on the right hand side, will be positive pi, and using the values of a and b as 10 inverse x and 10 inverse y is equal to this. And this is the proof of the second part of the formula, and both of these two formula is given in your book, but proof is not given in your main book. So I am giving proof also here to get the more concept on this part. So today we leave the class here. In the next class I will take some more properties of inverse trigonometric functions. So today we finish this class here. So thank you very much.